Good morning one and all. Today our topic is deep compaction. Already in last class in mechanical modification where that deep compensation is required, what are the various techniques which we are going to use in deep compaction we understand in our previous class. Now here we have to understand what are the various other techniques which were involved in our deep compaction. In this vibro flotation techniques, it is one of the ground improvement technique used and we are using this for hydraulic power, hydraulically probe and powered electrical, which we are used for this vibro techniques. In this vibro technique, what are the various suitable? It is suitable for granular soils. It is suitable for both granular and cohesive soils. In this vibro, coming to the practical purpose, various forms are available for this vibro flotation. In that, vibro compaction, stone columns and vibro replacement. These are the three different practical forms which we are using for this technique. In this, we are using, coming to this vibro flotation, the length is in between 2 to 3 meters, diameter is between 0.3 to 0.5 meter and the mass is 2 tons and it is lowered into the ground and vibrated. So this is the vibro float. This is the vibro float. It is penetrated and once it is into the ground, it is going to be vibrated. So like this. So for the loose granule, so the water jet, whenever the water jet, and these are the vibrator based on the water jet, and this is the for the column of sand, and whenever the treated depth up to 35 meters produce relative density 80%. So this width is equal to 2 to 4 meters. So like this, the vibro compaction process is going on. Coming to the other technique, that is the stone columns, another practical technique for the deep compaction. The another one is stone columns. Coming to the stone columns are a ground improved technique to improve the load bearing capacity of the soil. Why we are using this? Finally, the ultimate goal is improvement the ground quality for required construction work. What are the that particular project or construction work, what it needs. So that is the final goal for the ground improvement technique. In that, in the deep compaction technique which we are, it is used to improve the load bearing capacity of the soil. So in this, stone consists of crushed coarse aggregate of various sizes. In this stone column, the stone. So in every aspect, the name itself tells something for us. So in that, the important one is stone. Coming to the stone consists of crushed coarse aggregates of various sizes and applicable to wide range of soils, and stone columns are best suited to cohesive soils. This type of deep compaction technique is suitable for cohesive soils. So in these, coming to these installation process, in these, that whenever we are using the different kinds of borehole methods and rammed stone column, in these vibration methods, vibro flotation or vibro composer. Vibro flotation, vibro composer. In this rammed stone method are cased whenever the borehole method, these various techniques which we understand. In these, it is proposed, the proposal by the different developer by the 1982 and 1977 it is developed and uses a bore filling rig to dig the borehole and granule fills is placed and compacted in stages. So here we are going to remove and places with the coarse aggregate like this. So we are going to, here we are going to filling the big borehole in granule fill whenever that is placed and compacted in different stages which we are filled. So we are going to fill and we are going to in different stages we are going to compact it. So we are filling and we are going to filling, and after that we are going to compact the stones. In this, whenever we are using this rammer, the rammer here, that is the rammer, that is weight in between 15 to 20 kilonewton, falling through height of 1 to 1.5 meters for compacting the stone. So here the rammer for compacting the stones, whatever we are pouring into the, whatever we filled in that size of the column, based on the required size. So we are going to compact that using the 15 to 20 kilonewton falling height of the rammer, which is having that weight which is falling from the height 1 to 1.5 meters for compacted stone aggregate. It is economical than vibrator compaction. Coming to the vibrator compaction, here it is a machinery and it is very huge. Whenever compared to both the rammer stone column is more economical. In this method, the borehole is made by spiral auger and the borehole is cleaned by using specially made tools. In this, 2 to 75 mm size stone aggregate and 20 to 25% of sand is used. And the aggregate and sand layers are placed alternatively with layer thickness of 300 to 500 mm respectively. In this ramstone column, this is the procedure. First, we are going to cage the borehole and we are filling the material, that granule material, which is backfilled up to 2 to 3 from surface, and each layer compacted using the rammer. Here we are compacting based on the layers. So each layer of the rammer is going to compacted and casing withdrawn in different stages. Coming to the next one is the vibro flotation. So in this formation of stone columns using a vibro float is quite suitable technique for improvement of the cohesive soils. In this, the vibro float is allowed to sink into the ground due to its own weight. So associated by water or air as a flushing medium up to the required depth. So in this, we are using that water is used as a jetting fluid for fully saturated soils, while compressed air is used for partially saturated soils. It simultaneously releases water from the lower jets, which remove the soft soil directly under the vibro float nose from a hole. And this is the vibro flotation. These are the 4 different stages which we observe in this. The one is, first we are going to prepare. After that, the next step is the penetrate. Next one is the stone feeding. Next one is the compaction. This is the process which we follow for the vibro flotation. In this, first we are prepare where the location is there. We are going to prepare. After that, we are going to penetrate the vibro flotation machinery. After that, we are going to feeding this stone. Here clearly we observe the difference between these two. So here this is completely penetrated. Here it is going to feed. So observe these two. And after that we are going to compact like this. So this is the vibro flotation. So coming to these applications of the stone columns. The stone columns are act as vertical drains. So observe, these are like vertical drains. That's why these are like drains and they look like a vertical to the ground. That's why those are called vertical drains, and the speeding of the process of consolidation. So these here, they are speed up the consolidation process. So when replaces the soft soil by a stronger material. So whenever the ground improvement, whenever the ground which is constructed, a required project, whenever it is buildings or bridges, whatever it may be, the soft soil is there, but the requirement of the project is we should be done by in particular locality. At that particular place, the replacement is required. So whenever we are going to that replacing the soft soil into the stronger material, it gives the strength to the structure as well as the in various parameters, in various properties point of view of those material is going to increase. So it depends upon the how much material is required, which type of material is going to fill in that replace the soft soil, and how the soft soil is there and how much quantity of the strong material is required. These are all the parameters which is helpful for better understanding the or gives the better ground improvement to the particular soil for the better construction work. It's very important for understanding the various soil properties and how they behavior after the construction of the required project. So once we understand those parameters, we can easily identify which type of technique is suitable for the getting the final required ground improvement. So in this, we are replaces the soft soil by the stronger material. It means stronger into whenever the required material, and which type of material is required for the type based on the which type of construction is going to do in that particular locality. So these are the various factors for this understanding of the for applying the stone column. These are the various parameters which we are going to involve in these techniques. In this initial compaction of soil during the process of installation, thereby increasing the unit weight. And these are the various design parameters which we are going to understand for the methods and for the what are the patterns which we are going to understand in this. These are the various design parameters which we are keeping your we have to understand clearly, then only we are going to replace the required material, and we are whatever the values we are required for the better designs, for getting the better analysis also. In these vibro displacement and replacement methods, these feed methods in these top to bottom, those feed methods and whatever the pattern. So those are the various important parameters in these. The typical spacing, and the spacing is 1.5 to 3.5 meters. Coming to the triangular pattern, this is the formula. Coming to the regular pattern, this is the formula we are using. In this 0.6 to 1 m diameter depending on the material. So every time which type of material is there, those properties and required material what required properties and which material is satisfied the required properties. These are all the various parameters which we are understanding. Those characteristics gives the better understanding for the giving the better improvement to the particular ground. So in this, and the length up to 20 meters, it depends, and the crushed rock size is 20 to 75 mm, and design loads is between 20 to 50 tons. So these are the design parameters. And coming to the design considerations, the stone column diameter, the variation in the pile diameter installed by the vibro float, and this diameter 300 to 500 mm varies between 0.6 meters and 1.1 mm. It depends upon the type of the soil. So it is for 0.6 stiff clays, 1.1 mm very soft cohesive soils. The pattern arrangement also it depends upon the based on the characteristics. Based on characteristics or based on the properties which we are going to understand this design parameter arrangement also. Coming to the spacing, the column spacing may broadly ranges from 2 to 3 meters depending upon the site conditions. So every design consideration it depends upon the which type of property, based on the properties, site conditions and various characteristics involved and required properties. So for that, and which type of soil it is, and which size of granule column, the size of the coarse aggregate which we are considering for the filling also plays a major role for the design considerations. In this, coming to the next one is that is replacement ratio, the quantity of the amount of soil replaced by the stone. The term replacement ratio as is used 0.907, and this is the formula d by square, where the constant 0.907 is the function of the pattern used, which in this case is commonly employed equilateral triangular pattern. And the next one is the stress concentration factor. The next consideration is the stress concentration factor. The stress concentration factor, which is denoted by N due to externally applied load, is defined as the ratio of the average stress to in the stone column as well as the based on the average stresses and the stresses. So in between the value lies between 2.5 to 5. And the next factor is the stress. So this is the formula for whenever we are using for the triaxial state of the stress in the stone column and for the both column and surrounding soil at failure. So the ultimate vertical stress and the stone column and the lateral confining stress and the coefficient of the passive earth pressure of the stones. These are the parameters, and all these three parameters is in this equation form. So the settlement consideration also one of the important parameters. So in this consideration, we are considering the settlement of the composite soil using this formula, and based on the coefficient of the volume change, vertical stress and thickness of the treated soil. So that gives the settlement, consolidation of the settlement. And the next one is the soil, which kind of aggregate. The design consideration is one of the important parameter, that is the aggregate, where we are considering and how the crushed stone or gravel, which is chemically interact and devoid of the organic matter, and how hard it is, and for constructing the aggregate column. And the well graded stones are 75 mm to 2 mm may be used, and it depends upon the pile spacing, how much it depends upon the how much spacing is there, and for the based on the which type of pattern. So based on the type of pattern also we are going to identify and consider the size of the aggregate. And the coming to these serve cracks, what are the various disadvantages also we are going to face for these stone columns. In these, the stone columns are due to the vibrations of 30 to 50 Hz. This is the next one is the dynamic compaction. Deep dynamic compaction. In this, pounding the ground by a very heavy weight suitable for granular soils and landfills. So this type of dynamic compaction is suitable for granular soils and landfills. So this is the process which we follow for the dynamic compaction. And coming to the advantages of the dynamic compaction, whenever the compacts large areas of a loose granule fills, so and reduces the volume of the landfill waste and increasing density, and the voids are collapsed, and it increases the bearing capacity of the soil. These are the some of the advantages which we get. These are the properties which we get for the required ground improvement for using this dynamic compaction. Some of the disadvantages also in this, the dynamic compaction is the combination of soil profiles and the vibration could cause the disturbance and possible damages of the surrounding structures is the major disadvantages for this dynamic compaction, deep dynamic compaction. So in this, in place desanification of the granular soils, blasting by explosives. So because of this is the one of the reason of the dynamic compaction disadvantage. The range of soil grain sizes suitable for the compacting by blasting method is the same as for the vibro flotation. In this method, the compaction is achieved by the successive denotations of the small explosive charges in saturated soils. These relative densities of 70 to 80% up to a depth of 20 to 25 meters can be achieved. So for the above are the various types of Deep compaction methods which we use, the major are the vibroflotation, stone columns, deep compaction, dynamic compaction. These are all the various parameters for the required soils. So coastal soils suitable, deep compaction is there, granule soils having different types of adoption. So it depends upon which type of the ground level it is. So all these these are the some of the web references for this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.